All right, algebra. Was starting to make a video before my alarm went off to post these videos. So I'm going to start again so you don't have an alarm going off during the video. Now we are going to be working on quadratics and solving quadratic equations right now by answering some basic questions. Axis of symmetry, vertex, y-intercept, maximum, minimum, domain, and range. Some of them you're going to be able to do without having to do any work. Others, you'll have to do a little bit of work with this. Like I know parts of this right now. Negative 5 at the end, the c value, that is always the y-intercept, okay? So the y-intercept is always the c, and in this case, it's a negative 5. That means I know I crossed the y-axis at negative 5. I know that. It tells me right in the problem. Now, it also tells me more with this negative sign up in here, but we'll get to that in a little bit. Axis of symmetry. How do I find the axis of symmetry? X is equal to negative b over 2a. Axis of symmetry is how you split your graph into two equal parts, okay? It's the same on both sides of your axis of symmetry. Negative b over 2a. B is negative 6, so it's a negative 6 over 2 times a. Well, a is a negative 1, so 2 times a negative 1. But it's all, the whole thing will be negative. So negative 6 divided by negative 2 is a positive 3, but because this is negative, your axis of symmetry is negative 3. So over at my graph, I can make my axis of symmetry right here at negative 3. That's the folding point of our graph. That is the dead center middle. It splits our graph perfectly in half. Now, where is our vertex? Where is the peak or valley of our graph? Well, the vertex is simple. We found out what x is. All we have to do is fill in the ordered pair. Fill in x to find out what y is. Well, if x is negative 3, we take this negative 3 back up to here. Negative 3 squared is 9, but it's a negative 9. Negative 6 times negative 3 is a positive 18 minus 5. Negative 9 and 18 make positive 9. Minus 5 make a positive 4. So my axis of my vertex, since I know the axis of symmetry was negative 3, and I found out when I substituted the x, my axis of symmetry number, into my equation, my original equation, it came out to be a 4. That means the vertex of our graph is negative 3, 4. So I go back to my graph, negative 3, positive 4, right there. That's the vertex, okay? Now there's one key thing in this problem. Look at the number, the a value in this. It's a negative. I know immediately that this is going to be, my vertex is going to be a maximum. It is the highest point in my graph. How do I know that? Because it tells me it's a negative graph. That means it opens downward. And once I find out my vertex is negative 3, 4, I know that if this is over here, 1, 2, 3, 1, 2, 3, I balance my scales, my graph should look something like that. I don't really need to do any more, okay? I know that it's a maximum. I know my vertex is negative 3, 4. I know my axis of symmetry is negative 3. I know that it opens down because it is a maximum, but now the domain and range. If you remember before, I told you the domain is always all real numbers for what we're doing right now. All real numbers, because I can choose any value I want on the x-axis. But my range has a limit. It has to be all numbers less than right here. My y values can't go above here because there's nothing above there, because this is my maximum value. That's my maximum. So that means it's going to be all numbers that are less than y, or my range. All my range values will be less than or equal to, what did it come out to be? 4. Okay, so my range is all numbers that are less than or equal to a positive 4. Okay, This is what you have to do for these types of problems. You have to be able to find the axis of symmetry. You have to be able to find the vertex from there. You have to be able to find the y-intercept. You have to know, is it a maximum? Is it a minimum? You have to be able to find the domain. You have to be able to find the range. Now, again, some of these are disgustingly easy. Some of them, like your y-intercept. You just have to look at the original equation and know this is the y-intercept, the c value, the -5. That is your y-intercept. Simple one. No math needed there, just an ounce of intelligence to be able to look. You know automatically the domain is all real numbers. Pretty simple. That's an easy one for everything that we're working with. The domain will be all real numbers. You knew when you looked at the original equation that the number in front of the x squared, the a, was negative. So automatically, if the a is negative, you know it's going to open down, and that your vertex, which we don't know, the vertex is going to be a maximum. So you know the domain, the min or max, and the y-intercept without having to do any work whatsoever. The only parts that you have to do work for are to find the axis of symmetry. Then from there, you can find the vertex. And if you find the axis of symmetry and the vertex, you know the range, because you know how much it can go up or down or what the maximum is. Okay? Makes sense? Well, this was from your homework for today, or your work for today, from page 532. This was number 34. Now, I'm lying to you. This was not number 34. This was number 37. Number 37 is going to be part of your work for today. I'm going to assign you numbers on page 532, numbers 34 through 39. You have to do this work right here. Find the axis of symmetry, find the vertex, find the y-intercept, tell if it's a max or a minimum, and find the domain and range. All from an equation. You don't need to graph it. I mean, it's nice to be able to graph it off to the side and be able to know max, min, here's my this or that, and here are my points. Okay, they may ask you to graph stuff. It's that easy. You don't need to make that T-bar graph anymore. You can just use your information that you get when you know the y-intercept, you know the vertex. The y-intercept is going to balance itself out across the axis of symmetry. If you have any questions, send me an email. I want you to do, like I said, page 532. Page 532, numbers 34 through 39. 34 through 39. I just did number 37 for you. Okay, I'll post this. If you have any questions, I'll do more. I love these problems. This is fun math, where it's just set it up, work it out, plug it out, easy. Alrighty, I will talk to you later. Good luck on page 532. Thank you.